So with level 8, we are on to the home stretch of talking about trig functions. So if you think way back to level 6, we started with sine, cosine, tangent, what their graphs are, what the domain, what the range is. Then with level 7, we talked about the inverse functions, so inverse sine, inverse cosine, what their graphs look like. And then we talked about trig identities. So we did the Pythagorean identities, we did the sum and difference identities, and we did the double and half angle identities. Well, now we've reached to level 8, and this is our applications section. So we're going to be doing applications involving right triangles, aka story problems. And then the two other sections that we're going to talk about involve trig with non-right triangles. So if we don't have a right angle, we can still find information about the sides, and that's where things called the law of sines and the law of cosines comes into play. And we'll get more into those when we talk about that. So things you should know, right triangles, you should be able to solve those. You should be able to solve any story problems with right triangles. Plus, use the law of sines with side angle angle and angle side angle. We will talk about something called the ambiguous case that comes up with law of sines, and then we will know how to use the law of cosines. All right, so let's get into it with 8.1 involving right triangles. So level 8.1, things we should already know coming into this. This is the things that we learned from geometry. So SOHCAHTOA, if we haven't seen that already before, or TOA, SOHCAH, as some people know it. SOHCAHTOA. Sines opposite over hypotenuse, cosines adjacent over hypotenuse, tangent opposite over adjacent. Cosecant, secant, cotangent are the reciprocals, so we just flip those. And then if you're wondering where these come from, we always label in a right triangle, we have capital A, capital B, and capital C for our angles. And we have little a across from A, little b across from B, little c across from C. And just so we know, we've seen this since 6th or 7th grade. The Pythagorean theorem, a squared plus b squared equals c squared. Okay? Something new that we should kind of know is something called the complementary angle theorem. So the complementary angle theorem says cofunctions of complementary angles are equal. Okay, so what are our cofunctions? Now, not our reciprocal functions, but sine's cofunction is cosine. Sine and cosine are cofunctions. So as you see here, complementary angles, which means complementary means adds up to 90, if we didn't know. So complementary angles, 30 and 60, that means the sine of 30 is equal to the cosine of 60. So on our unit circle, we know that. We know what the sine of 30 is. We know that the sine of 30 is 1/2. And we know that the cosine of 60 is also 1/2. So cofunctions of complementary angles are equal. So the cofunction to tangent is cotangent. These are our cofunctions. 40 and 50 are complementary, so these two are equal. Likewise, complementary angles of cofunctions, so secant's cofunction is cosecant. Okay, so that's a thing that we kind of know, but it's important that we do know. So if we have our triangle set up, why this would be helpful for us is we have C, we have A, we have B, right angle, A, B, C. The sine of B, which is B over C, is the same thing as the cosine of A. Or the cosine of B, which is A over C, is the same thing as the sine of A, which is A over C. Or the tangent of B, B over A, is the same thing as the cotangent of A. So whatever information we have, we can use the fact that we know sine or cosine to get different angle informations. So let's try this out. Given this picture to the right, a rain gutter is constructed of aluminum sheets 12 inches wide. So this is altogether 12 inches. After marking off 4 inches of each edge, this length is bent up at an angle. Okay, so we bend it up to an angle here, we bend it up to an angle here. Express the area of this whole shape as a function of theta. Okay, so in order to do this, we know that this is 4. Our angle right here is theta. Our angle right here is theta. And this is 4. And then, I know this is not to scale, but this is 4. Okay, so what I would suggest we do is we have 2 triangles and we have a rectangle. So with the area, we have the 2 times the area of our triangles plus the area of our rectangle. The only other thing that I need you guys to remember is if these are parallel, find your z angles. Those are your alternate interior angles. Your geometry teacher would be happy if you guys were able to recognize those. And then this is where trig comes into play. So once we have our angle inside our triangle, the sine of this angle up here, let's just call this y and this x. The sine of our angle is equal to y over 4, or 4 times sine theta equals our height. Same thing here. The cosine of our angle, x over 4. Cosine of our angle equals x over 4, or our x value is just 4 cosine theta. Now you may be saying, why do I need to know that? Well, x is our base, y is our height. So we have 2 times 1/2 x times y plus the height is y and the base is 4. Well, if we solve for y and x here, we can put our area all in terms of our formulas. So then I'm just going to do a slightly different color. 2 times 1/2 cancels. So x times y is cosine theta times sine theta plus 4 times, both of these are 4. So this is 16 plus 4 times whatever y is, 4 sine theta. So I have 16 cosine theta sine theta plus 16 sine theta. That is the area of this shape, all in terms of theta. And all we have to do is note that sine is sine of an angle, cosine of an angle. If this looks familiar and you're in physics, it's because we are just finding the component pieces, knowing the triangle. All right, flip it over. We'll do a couple more applications. So with example 2, we're just given a triangle and it says find the missing pieces. So a lot of these problems will say, okay, give you a couple pieces of information, draw the picture if it hasn't been drawn for you. So first step in all of these, if you haven't, draw a picture. It's going to help you out a whole lot. Okay, so B is 2. Angle A is 40. Find AC and B. So we should be able to find angle B right away because 40 and B are complementary. So B is 50. That we should get really quickly. To find A and C, we can do a couple of different things. If we did the sine of 40, would that be helpful? Sine of 40 is A over C. We don't know any of those, so that's not really helpful. If we did the cosine of 40, that would be 2 over C. So then to solve for C, we can multiply both sides by C, which is weird because it's C times cosine 40 equals 2, or C equals 2 divided by cosine 40. So you type this into your calculator. Make sure that you are in degrees. I will just show you. I've already made sure that my calculator is in degrees. So I'm just going to type in 2 divided by cosine 40. Hit enter. Hit control enter. I get 2.61. Now, that's my C. I could do the Pythagorean theorem. I want to stick with using trig. So the tangent of 40 is equal to A over 2. opposite over adjacent. So then A equals 2 times tangent 40. So again, once you get that, 2 times tangent 40, hit enter, we get 1.67, 1.68. 1.68. So there's A, there's C, and there's angle B. Okay. Example 3. A is 3, B is 2. Find C, A, and B. Simple enough, right? First off, we're going to use Pythagorean theorem to find the third side. Then we have a lot of different choices. So 2 squared plus 3 squared equals C squared. Or 4 plus 9 equals C squared. C equals the square root of 13. Keep that as an exact answer. So that helps us find our angles. Now, we could use root 13 in all of this, or I could just say tangent of, let's say B, equals opposite over adjacent. Now with level 7, we know how to undo a tangent is just take the inverse tangent of both sides, or the inverse tangent of 2/3. So calculator, we're going to go trig, inverse tangent of 2 divided by 3. We're in degrees here. So we get 33 point, and I'm going to round that to 7. So we get 33.7 degrees. That's the only angle I have to find because A equals 90 minus B. So I'm going to go to my calculator, 90 minus whatever B was, and I get 56.3. So A equals 56.3 degrees. So there's my A, there's my B, and there's my C. What if we get to a story problem? So oftentimes in the book, and I'm sorry that this is a little hard to see, I know in the notes, it's a lot clearer in the book. So a surveyor can measure the width of a river by setting up a transit at point C. Okay, so point C is here. On one side of the river, taking sighting point at A. Okay, here's A. After turning through a 90-degree angle, so that gives us a right triangle, the surveyor walks a distance of 200 meters. So they're going to walk along the river and go to 200 meters and finding an angle to be 20 degrees. What's the width of the river? Or better yet, what's the distance from A to C? So having all this information inside the picture, all we want to know is how is B and A related? Well, we have opposite and adjacent sides. So that's tangent of 20 equals B over 200. So to solve that, multiply both sides by 200. B equals 200 tangent 20. So again, we go back to our calculator. 200 times the tangent 20. Control Enter. We get 72 point, and I will round that up to 72.8 degrees. Sorry, this is not degrees. 72.8 meters, because that's the distance. Example 5. A straight trail leads from the Alpine Hotel, so here's the Alpine Hotel, and with an elevation of 8,000 feet. Okay, so the hotel starts at 8,000 feet, so that's your 0. And it leads up as this trail that's 11,100 feet. So the total height of this hill is, and they give it to you, 3,100 feet. The length of the trail is 14,100 feet. So from the hotel up to the scenic view is 14,100 feet. If this is hard to see, I will redraw this triangle because it's saying, what's the inclination or what's the angle measurement? And I think they call it B, so I'll call it B. This is 3,100. That's a right angle. This is 14, 100. So we have opposite and we have hypotenuse. So opposite hypotenuse should be sine. So sine of B equals 3100 over 14, 100. Take the inverse of both sides to undo sine. Solve for our angle. B equals inverse sine of 3100 divided by 14, 100. Now we just go back to our calculators. So inverse sine of 3100 divided by 14, 00. Hit enter one more time. We get 12.70 degrees, or 12.7 degrees. So these story problems, all it is giving you a right triangle. We have one more page of these, and then we're done with 8.1. All right. So example 6 looks really difficult and complicated because there's a long story involved in this. So I will read it, and then we will break it down. Meteorologists find the height of cloud using an instrument called a cielometer. A cielometer consists of a light projector that directs a vertical light beam up to the cloud base and a light detector that scans the cloud to detect the light beam. On December 1st, 2014, Midway Airport in Chicago, a cielometer was employed to find the height of the cloud cover. It was set up with its light detector 300 feet from its light projector. So light detector, light projector. If the angle of elevation from the light detector to the base of the cloud is 75 degrees, what is the height? So we take this and we're given this picture. We want to find the height. We have an angle, we have this side. So the angle, opposite, adjacent. So if we have opposite, adjacent, that is tangent. So tangent of our angle equals the height over 300. So multiply both sides by 300. 300 tan 75 is our height. So we go to our calculator, we type 300 times tan 75, and we get 1,120 feet. So the height of those clouds is 1,120 feet. And we know that because that's our unit right there. So those are some pretty low clouds. Last problem. So, adorning the top of the Board of Trade building in Chicago, there's a statue. Okay. The Roman goddess of wheat. From the street level, 2 observations are taken. 400 feet from the center of the building. Okay, so we got this here. The angle of elevation to the base of the statue is found to be 55.1 degrees. The angle of elevation, which means angle of elevation, this word right here means how much it goes up. So we have 2 angles of elevation. So top of the bottom of the statue, the top of the statue. In order to find the height of the statue, we're going to use these 2 letters, B, and we're going to say this is H. What we want to do is find the height of all the way at the top of the statue minus the height of the base. And if we do that, we'll get how tall the statue is. So in both of these, we have opposite and adjacent. So sine, opposite adjacent is tangent. So tangent of 55.1 equals B over 400. So 400 tan 55.1 equals B. And I'll just set up H as well. So tan 56.